A couple of months ago, websnarf and snowfeet started a campaign to collect data on religious identity on YouTube. The set of questions posed were many, and with many alternative answers to many of the questions. The object was, among other, to see if there were fewer female than male atheists. In order to compare, efforts were made to collect data from other groups than atheists too. As I understand it, Golden Gun 85 spearheaded an effort to collect data from Christians. Subscribers to websnarf, snowfeet or Golden Gun 85 posted these videos as their favorites, thus making the survey more available. The data has a certain skew towards atheism and maleness, meaning that you cannot simply look at how many atheists that are male and female. Rather, you need to do a contingency table analysis. You count the number of people who have answered a given combination of two questions and see if there's a trend, a dependency in the answers. I'm using background intensity here to further illustrate the data. The requirements for doing this analysis is as follows. The skew towards, for instance, maleness in the survey has to be the same whether you're an atheist or not. Whether this is so or not can be debated. 2. People need to understand the questions and answer truthfully. There are some very weird results here, like an atheist who believes in creationism, or 13 people who think the Earth is less than 5,000 years old, younger than creationism claims, and younger than written history. Amongst these were 2 atheists, and there were people who believed in Abiogenesis, creationism, and evolution. Still, as long as these are in a minority, they'll hopefully just be noise. 3. No person-to-person dependency. If we got a Catholic feminist in the survey, the probability for getting another should not increase. The zero hypothesis, age 0, is that the probability of ending up in a given cell in the table is the row probability times the column probability. So the probability for being a female atheist should be the probability for being a female times the probability for being an atheist. The alternative hypothesis, age 1, is that anything goes, as long as the cell probabilities sum to 1. I'm going to use 2 tests, both based on the same model premises, which are exact. The 2 tests differ in that they are founded on 2 different schools of statistics, namely frequentist and Bayesian. In addition, I'm throwing in the easiest of the approximative methods, the chi-square method. In Bayesian testing, you need the probability for the data and the age 1 divided by that for age 0, the base factor. This is more difficult than it sounds, since the row probabilities, column probabilities, and cell probabilities are not readily available. So you need to integrate over these. I managed to do all but one, which can be handled numerically. It turned out that someone else had managed to do the integral though. The formula, however, needed a sum over all possible datasets with the same row and column sums. This makes handling large tables with lots of categories, both for question 1 and 2, very impractical. The really neat thing with Bayesian statistics is that the data can pull in the direction of the simplest hypothesis, age 0, so that it's got Occam's razor built into it. Still, if this happens, it can be because age 0 is true, or that there's not enough data to support age 1. The larger the tables, the more data is needed. When the base factor is calculated, you can put it into Bayes' formula. I've done this for 50-50 prior probability for and against independence. In frequentist statistics, you instead calculate the maximal probability for getting something as extreme as you did, given that age 0 is true. Age 1 defines what extreme means. If this so-called p-value goes below a predefined significance level, we say that age 0 is rejected with confidence 100% minus the significance level. If we want a significance level for a string of tests, we can divide the original significance level with the number of tests and use that as the individual significance level. There are at least two frequentist options here. Fisher's exact method is just that. It has the same practical problems as the Bayesian test, as you need to identify all possibilities more extreme than what you got. The chi-square test can be done with a calculator and doesn't become impractical for large tables. You simply compare frequentist estimates for the expected cell counts under age 0 and use the central limit theorem to make a test statistics. However, since it depends on large data approximations and large tables will typically have low cell counts, it will fail for large tables, just in a different manner. I've described frequentist methods as quick and dirty before, and nothing here fits the bill better than the chi-square test. Still, sometimes quick and dirty is all you got time for. Since it's such a transparent method, I'm using the contributions to this test statistics from each cell in order to identify the largest contributions to the assumption of dependency. There's another reason for keeping tables small, namely that the difference in complexity between age 0 and age 1 will be great for large tables. That means that you need lots of data in order to make age 1 a viable prediction model. For more moderate data sizes, age 0 will outperform it. Thus I ended up dividing the countries into USA and not USA. As a Norwegian, I'm far from happy with such a USA-centric way of viewing the world, but it's necessary with the data we got. Similarly, I divided religious identity into Abrahamic, agnostic, atheist, and other. I was planning to keep pagan Wiccan as a category of their own. I did get some results doing that, but those may have been caused by person-to-person dependency, and it made too many problems with the table sizes. For the question with multiple answers, I only kept the belief set, dividing it into yes and no for each belief. Here's the results for the gender-religious identity issue. Background intensity here is used for showing the contributions to the chi-square test, with intense blue for when observations are lower than expected under age 0, and red for observations higher than expected. Since there is only one test here, I'm using the standard significance level of 5% for the frequentist tests. All tests indicate age 1 dependency. The numbers in parentheses are the expected counts under independency age 0, while the bracketed numbers are the contributions to the chi-square test statistics. As can be seen, the largest contributions are that there's fewer female atheists than expected and more Abrahamic females. Next, I'm going to look at religious identity versus all the other questions I've kept in my version of the survey.